This is Unit 3, Objective 1, Measures of Central Tendencies. So the title is actually a really key word in this, or key phrase in this, measures. So we're looking at measurements of central tendencies. So these are middles, basically, I like to call them. All of our different types of middles. Okay, we're going to talk about 4 types of middles. We have mean, median, mode, and mid-range. All right, so the mean, we've already talked about this before. Most people know this as the average. Okay, this is where we add it up, but I'm going to start introducing, I actually use different colors for these. I'm going to start introducing we'll call it the statistics formulas, not just what you've learned before in previous classes. So this is x bar equals the sum of x over n. And we also have mu, this is the Greek letter mu, equals the sum of x over n. Okay, where the sum of x means sum of the data, add up all the data, and n represents the number of data points, how many data we have. So it's the same formula as you had before. Add them all up, divide by how many there are. That's the same thing. Okay. So I'm not going to spend too much time with this. Where I'm going to spend the time is the symbols. So we have x bar, call it x bar. This is the sample mean. Okay, we're going to get a lot of these variables, so you want to start recognizing them. And then we have the Greek letter mu. Just to let you know, I draw it terribly. So it's a U technically with an extra tail on the front. That is the Greek letter mu. So we have x bar and mu. Mu is the population mean. Okay, this is our first distinction between a sample value and a population value. You're going to see lots of different symbols that we look at. And you're going to have a lot of variables to memorize, know what they mean. But this is the sample mean, population mean. Okay. Then we have the median. Most people know this as the middle number. Okay. A lot of people don't realize that when we talk about central tendencies, when I talk about the middles, they assume it's always the median. Be careful. It's not just the median. These are all types of middles. They're all types of centers, just different ways of describing the center. Okay, so this is the middle number after the data is ranked. Okay, that is an important part. Don't forget you need to rank the data first, usually lowest to highest. Okay, so we do have a formula for this one. It's actually a depth formula. It's helpful for when we have large data sets. So that's why it's the depth of the median. So the D represents depth, and then parentheses is the of, and then x tilde, or x squiggly, that's the symbol for median. So the depth of the median is n plus 1 divided by 2. Okay. So I'll write it out in words. Depth equals number of data points. It's the n. Notice it's the same thing. Plus 1 divided by 2. Okay. And x tilde, x tilde, or x squiggle. I sometimes just call it x squiggle. That represents the median. Okay, notice there's no distinction between sample and population. Generally, it's just one value, the sample, so we only have one symbol. Okay, then the mode, that is the value that occurs the most. Okay, that is a middle when we're talking about qualitative values usually. That's when we use the mode, is for qualitative values. And finally, we get the mid-range, okay, which is another middle. It's exactly midway between the low and high value, the lowest and highest value. lowest and highest values. Okay, so we have a formula for this. This one does not have a fancy symbol. It's not used as much. So it's the low number plus the high number. You add them up first, and then you divide by 2. Okay, so we're actually going to do this a few times. All right, so you always need to tell, is it a sample or is it a population? It doesn't matter quite yet, but it's going to become a very important distinction. So we're going to start pointing this out now. Okay, so this is sample data. So we're dealing with sample data here. Okay, all right, so we look at our sample data. It's not ranked, so we'll rank it when we get to the median. For the mean, though, I don't need to rank it. I just need to add them up. Okay. So I add them up, I get 15, 35, 38, 49, divided by 5, which that's 9.8. So my sample mean, using the correct variable there, is 9.8. Okay, so I actually probably should have put that in the front. Sample mean. X bar is sample mean. Okay, next is the median. Okay, so I got to order it. 3, 4, 11, 11, 20. Okay, so most people have learned you count in, so count one in from both sides, one more in from both sides, and the middle number is the median, which does work. But I'm going to use the depth formula because that's the new thing. We want to practice using it, and I want to show you how it works. So the depth of the median, d of x tilde, equals the number of data points, which is 5, plus 1 divided by 2. Okay, so I add them up, I get 6 divided by 2, which is 3. But this is the depth, not the actual median, so be careful. I always write a little erd or ist or th at the end there, because this is the position. So 1, 2, 3, third term, my median is 11. Okay, so that's how that works. When we get to things with like 50 data points, it's going to be a lot easier to do this and just count to the number you want than to actually count in. So that's why this is so helpful. All right, mode. This is always should be your easiest one. Which number occurs the most? 11. Done. And finally, mid-range. Take the lowest number, add the highest number, divide by 2. So 23 divided by 2 is 11.5. So my mid-range, no fancy variables for these last two, is 11.5. Boom, done. Okay. Next one. Really the same idea, but now it's a population data set. So we have to distinguish between the two. All right, so I have my mean, mu, because it's population mean now. 5 plus 7 plus 20 plus 3 plus 15 plus 15. Add them all up. Divide by how many there are, so 6 in this case. All right, so add them all up. I'm just going to use the calculator. Add them all up, hit enter, divide by 6, and you get 10.8. So my population mean is 10.8. All right, next is the median. So we got to order it first. Put it all in order. So 3, 5, 7, 15, 15, 20. Some of them will be ordered, some of them won't be, so be careful about that. I can use my depth formula again. So I have 6 data points plus 1 divided by 2. And so I get the 3.5th term. Okay? A lot of people get confused by this. That means literally halfway between the third and fourth term. Right? 3.5 is halfway between 3 and 4. It's halfway between the third and fourth term. So 1, 2, 3, 4. So I need to find halfway between 7 and 15. Okay? So if you don't know what halfway between is, you add them up, divide by 2. You're actually finding the mid-range of those two values. Okay, so 22 divided by 2 is 11. So my median is 11. Okay. Realize it's not actually part of the data set, so be careful about that. All right, then we get to the mode. Which one occurs the most? 15. Done. Should be your easiest one every time. Mid-range, lowest, plus highest, divided by 2. So we get 23 divided by 2, which is 11.5. So my mid-range is 11.5. Okay, notice the work I'm showing. That is the work you need for your homework. Okay, so I need to see the setup for each one. The median, show me how you found the median. Order it and look at the depth. Mid-range, show me the equation. Mean, show me the equation. Mode doesn't have any work, but that's the only one. Okay, and for your homework, we throw in a little loop with things like GPA. Okay, if you didn't know, letter grades represent numbers in school. So that's where the 4.0, 3.0, 2.0, and so on come from. Zero point zero, I mean just 0. Okay, so we want to find the GPA of this student. So this student had 6 A's, 12 B's, 19 C's, 12 D's, and 4 F's. So we need to add them all up. Instead of adding 6 A's together, then 12 B's, that would take forever. We're going to use what we understand from multiplication and then multiply 6 times what an A is worth, plus 12 times what a B is worth, plus 19 times what a C is worth, plus 12 times what a D is worth, and finally 4 times what an F is worth, which is just 0, by the way. Okay, but on the bottom, we have to keep track of what is the total number of grades that we're adding up here. Okay, it's not 5. We're not adding up 5 grades. We're adding up 6 plus 12 plus 19 plus 12 plus 4, right? I have 6 A's, 12 B's, 19 C's, 12 D's, and 4 F's. Add all those numbers up. That's how many total we have. So we got to do this kind of separately. Do all the top and all the bottom, write it down, then divide. Okay, so type into your calculator all these up here. And you should get 110. Then add these all up, and you should get 53. And then following our round off rule, my data has 1 decimal, so my answer will have 2. 2.08 is their GPA. And that's how, if you didn't know, you can actually calculate your own GPA. Okay, so number 4, I just want to show a few things. We're going to compare the two data sets because we're going to have what's called an outlier. Okay, so you can look at the two data sets, 2235, those numbers are all really close together. 2235, we have one number that is off. So we're going to look at what happens with an outlier. Okay, so I'm actually just going to give you these. So my mean of this first data set is 3. My median is 2.5. My mode is 2. And my mid-range is 3.5. For the second data set, my mean is 9.75. My median is 3.5. My mode is 2, and my mid-range is 16. Okay, so besides the mode, all the other ones were effective. But we want to talk about why we have multiple central tendencies, right? Why don't we just always use the mean? Okay, and because in real life, we end up a lot of times with outliers. So you can do two things. You can throw out the outliers, which then you're throwing out real data, so you're not really representing things well, so we don't really want to do that. But we don't want the outlier to affect our value too much. And if you look, the mean and the mid-range are affected quite a bit, right? We went from 3 to 9.75 and 3.5 to 16. They're affected a lot by outliers. So if you have outliers within your data, your central tendency that's the best one to use is the median. If you have no outliers, then you probably want the mean. If you have a wide-ranging set of data, maybe the mid-range is the best. And then the mode, like I said, is for qualitative variables. All right. So when we compare them, we notice that 30 is an outlier. First of all, you need to understand that. It doesn't match up with the rest of the data points. Okay. And that the mean and mid-range are greatly affected by outliers. Okay, and that is why we have multiple central tendencies. We have different avenues we can go down to get the best summary of our data, right? If you remember from chapter 1, this is talking about your statistic and parameter, right? Summarizing data. So we want to summarize the data in the best possible way based on what we're given. So if we have a set of numbers and then one really far off number, an outlier, we might not want to use the mean and mid-range. It's not going to represent the data well. That median represents a much better middle of this data set than the mean or the mid-range, right? If we're looking at this data set, we're thinking, okay, what's the middle here? 3.5 makes sense. If you look at this data set, okay, it's a very simple data set. If we're talking about the middle, all three of them actually are well representing the middle. The mode might actually be the worst of all of them. And honestly, the median's not too great either because it's not representing, taking into account that 5 being much bigger than the 2s, right? So a mean looks like a really good middle for that case, okay? So that's why we have multiple, and that's why it's important to learn about multiple, because if you get into statistics, you have lots of different middles that are useful for different scenarios. Okay, so that's why we have 4 central tendencies we look at. Well, make sure you write your 3-sentence summary.